the empty container and the mass of volume is what you call mass of mass of liquid. Therefore, to find density of liquid, you must know what you must consider. Again, to calculate mass density of a regular shaped, you must consider what we have seen in our previous time. So, in our today discussion, we will see dimensional expression of physical quantity. When we talk dimensional physical quantity, we are going to talk, or we refer, or we are talking about the basic physical quantity or fundamental physical quantity contained in that body. For example, if you wanted to express dimension of density, you are talking about what?
Baby, I don't understand.
About what? About the basic physical quantity content and uh, density. And density. For example, when we talk about density, density is equal to mass over volume. Mass is what? In mass means it is basic physical, one basic physical quantity. When we talk about volume to have its own what? Its own dimension. That means volume is equal to length times width times height. Therefore, when we talk about dimension of density, we are talking the basic physical quantity and the dimension of what? Dimension of physical quantity, what we call density. Therefore, dimension of density is equal to ml the power of -3 or m over l cube. We will see this one by one. We will see one by one. For example, before that, from the previous time, let us tell you what is hydrometer, the meaning of hydrometer. Hydrometer is an instrument used to measure density of liquid. For example, the denser liquid, for example, if you want denser milk, if you wanted to check by thermometer, the thermometer depth to which hydrometer sink is smaller in the denser denser liquid. And the smaller of the density of liquid, the more, look, they are vice versa. The more depth to which the hydrometer sinks. If the liquid is more dense, the liquid sinks smaller. And if the liquid, the density of the liquid is smaller, more depth of hydrometer is sinks. So hydrometer is the instrument to use to measure the liquid of the densities of liquids. The other one is significance of knowing the density of material. Why we learn about density of material? You must know, for example, about airplanes, moving parts of engines, bodies of bus, etc. must be strong but not heavy. For example, the density of material, you must know. Why? For to apply an object as it is at its essential point. For example, if you take airplanes, the airplanes parts are very strong, but they are not heavy. Again, if you take the parts of bus, they are very strong, but they are not heavy again. So to know about density of an object, it helps you on such a kind of application. Again, the density is important to identify pure substance like gold from mixture. For example, what is the density of pure gold? If you know the density of pure gold, you can identify from the mixture of gold from the others. And the other point is civil engineers use the idea of density to determine the durability of their buildings. For example, everywhere one book can check or can be checked from time to time. Why for? They wanted to express or they wanted to know the durability of their buildings. If they become know the durability of their building, they can they can repair or they can check what the building seems like at that moment of time. So this is why we consider or why we know the density of an object. Why we know the density of an object. Let us proceed to the concept of dimensional expression of physical quantity. Dimensional expression of physical quantity. Dimensional expression of physical quantity, as I have told it to you as the as introduction, refer to the fundamental unit or units contained in the body. For example, if you want to know dimension of density, density equal to mass over volume. We will see. The dimension of mass is capital M. Volume is equal to the dimension of volume is L cube. Or when we raise out this one, raise at the upper point M L minus 2. If you see mass, mass is fundamental physical quantity. For example, how many mass here? One. Again, length is a fundamental physical quantity or basic unit, a basic physical quantity. So express the terms or the basic physical quantity contained in it. For example, when you are talking about dimension of density, you are talking about the fundamental unit or units contained in the dimension of density. Again, dimension of velocity, dimension of speed, dimension of acceleration, and the etc. We will see. So every physical quantity can be expressed in terms of basic physical quantity. Every physical quantity can be expressed in terms of physical quantity. For example, if you take speed expressed in terms of distance and the time. That means speed is equal to total distance or distance per unit time or distance divided by time. So every physical quantity can be expressed in terms of what? In terms of basic physical quantity. So when we express in terms of basic as a physical quantity, in terms of basic physical quantity, we can express dimension of that physical quantity. For example, the dimension of in dimension system, capital M represent, for example, capital M represent mass or dimension of mass, capital M. This one is small, capital L, dimension of what? Dimension of length, capital M. And the capital T, time. So depending on this one, we can express other physical quantity. So, for example, volume is equal to length times width times height. So length, width is a type of again length or a kind of length. Height is a type of or a type of length again. So the dimension of volume is equal to length cube. We will see one by one. So for the system of units, the quantities M, L, and T are used to represent mass, length, and time respectively. So you must consider the dimension of mass is capital M, the dimension of length is capital L, and the dimension of time is capital T. So The power to which the fundamental units are raised to obtain any physical quantities are called the dimension of that quantity. The dimension of that quantity. For example, as I have said now, capital L is the power of 3 means if you see this power, how many lengths exist in this dimension? 3. Length times length times length means length q. The power to which the fundamental units are raised to obtain physical quantities are called dimension of that quantity. Okay.
Mr. Asama.
Dimension of that quantity. For example, the dimension of Asama. What about now? Aunis.
Aún يسمى.
يسمى
Yes.
Someone, Mr.
Connection the dimension of speed, if you take the dimension of speed is equal to length time over time. So the dimension of speed distance means a type of length or a form of length or other type of length, distance, height, base, and etc. are a type of length. So length over capital T. When you this one come to above, or T must be equal to L T minus 1. Minus 1 means over. If you multiply both denominator and denominator by T minus, this one cancel out and the above become LT minus 2. Therefore, the dimension of speed is equal to LT minus 1. So in dimension of speed, the basic physical quantity which exist are, or the basic physical quantities which contain in the dimension of speed
Mr. Asama. يقرر Mr. Asama.
Mr. Orarata.
يستاهل كورة
length and the time. Minus
Mr. Asama.
connection now. What about now? Someone?
أنا مقررت
يقرر
Wait, connection ሊሆን ይችላል እያልኩ ነው። Connection. አሁን አይሰማም እንዴ?
አሁን ይሰማል።
የእናንተ ይሰማኛል፣ ግን አልፎ አልፎ ይቆራረጣል። እሺ፣ አልፎ አልፎ ይቆራረጣል። አሁን
ሚስተር አሁንም ይቆራረጣል። ሚስተር እየተቆራረጠ ነው።
ኦኬ ኮኔክሽን ነው እና ጠብቁ፣ ይስተካከላል። Under dimension of expression of physical quantity, you must know. አሁን እንዴት ነው? አይሰማም? አሁን አይሰማም?
ይሰማል። ጥሩ ነው።
ይሰማል ሚስተር።
እሺ እዛ ኮኔክሽን ነውና ችግር የለም። Under dimension expression of physical quantity, you must know the basic unit which contain in that physical quantity. That means depending on what? Depending on the unit of what? The unit of that physical quantity. You must know the basic unit exists in that derived physical quantity, any derived physical quantity. For example, acceleration is equal to change of velocity over time taken. Change of velocity to time taken. That means change of velocity means meter per second. Meter per second means Meter expressed, or meter is the SI unit of length. Second means the SI unit of time. Over time again. That means the SI unit of acceleration is what? Meter per second square. Meter represent in dimension form. Meter represent in dimension form by L or capital L. That means length. And second means the dimension of time is equal to what? T, capital T. Therefore, the dimension of acceleration is m per t square, or mt the power of -2. We will see one by one this one. For example, have you seen this quantities which exist in the table form? For example, if you take the mass, the units of mass equal to what? The units of mass, kilogram. The units of mass is equal to kilogram. It is written on this one for time being. It is dimension is the dimension of mass is equal to m capital. It seems like this one. Dimension of length is equal to capital L. It is unities. Dimension of time or unit of time is second. It is dimension is T capital, okay? T capital. So when we talk about dimension of physical quantity express the basic physical quantity which contained in the body. The other points there are none dimensionless physical quantities. There are some of physical quantities are expressed without units. Some of physical quantities are expressed without or described without units. Only it is described by number independent of unit. For example, do you know the definition of mechanical advantage? Mechanical advantage, for example, in grade 7, your unit 5 under simple motion, mechanical advantage is equal to load over what? Effort. Load over effort. Don't worry about definition for today. What's the unit of load? It is Newton. Again, what's the unit of effort? Again, it is Newton. Newton cancelled by Newton. So some physical quantities like mechanical advantage, velocity ratio are dimensionless. That means they expressed or they describe without units, or they describe only by units. So they are dimensionless physical quantities. Example, velocity ratio. For example, another velocity ratio is equal to distance of effort over distance of
What's going live?
Distance of efforts is expressed by what? Maybe, for example, 10 centimeter or meter, or it can be, let us say, meter over 2 meter. Meter cancelled by meter. Again, you write 10 by 2, 5 without unit. Such type of or such kind of dimensionless physical quantities. Dimensionless physical quantities. Okay. There are some physical quantities which only by number.
I don't understand
Question?
why we are changing the power into negative.
Who said I have? Yes.
I don't understand
Okay,
why we are changing the power into a negative.
Okay, you didn't understand. Okay, I will go for you. Okay, look this one. For example, look. Density is equal to mass over what? Volume. Are you sure? The dimension of mass is equal to
Mr. Samam.
capital M.
Mr. Aisama.
Dimension of volume means length times width times connection.
ይቆራረጣል ሚስተር
ይቆራረጣል።
አዎ አይሰማም አዎ ትንሽ ሚስተር ይቆራረጣል ማስተካከል ይቻላል
ቆራረጠል ሚስተር
አራት ፉት በማርያም ዘፈን የከፈተ ሰው
why it become negative? For example, to bring up length, for example, 1 over L cube or L square means to bring this one up, it bring up by what? By negative 4. By negative 4. By negative 4. Therefore, to bring become negative, okay? It become negative. For example, to cancel the denominator of length cube, you must multiply by what? By length minus over the reciprocal of this one. Length minus over length minus. So here you multiply this one become 1, the above become ML minus, okay, why it become bring up, it considers this one is the multiplication or the mathematical concept, okay, mathematical concepts, okay. What about now? Have you understand?
Yes, it's clear.
Okay, the other point, yeah, okay, thank you. Look, fundamental physical quantities. From fundamental physical quantities, mass, length, and the time. We have seen it is dimension. We have seen it is dimension. What about derived physical quantity? Let us see it is dimension, okay? Let us see it is dimension. For example, physical quantities, derived physical quantities are area, volume, density, speed, force, power, and etc. They are many in nature. They are many in nature. For example, area means length times width. So width is, when we express width, length, they expressed by what? By capital L. Capital L. Therefore, the dimension of length is equal to L square. The dimension of length is equal to
ጽሁፉ አይታይ
Mr. Gorza.
ይቆራረጣል ሚስተር የምትለው ነገር ምንም ነገር አይሰማም
ሚስተር እየተሰማናል
ኮኔክሽን ነው ካላችሁ
አይሰማም ሚስተር
አይሰማ
ኧረ ምንም ነገር አይሰማም
እሺ ጠብቁ ይስተካከል
ሚስተር አይሰማም
እሺ
አረጋጉት
ተረጋጓ
ኮኔክሽን ይስተካከል ጠብቁ
ተረጋጉ
ኮኔክሽን አሁንስ አይሰማም
አሁን ይሰማል ሚስተር
አሁን ይሰማል
ይሰማል
አሁን ይሰማል ሚስተር
አንዱ ጋር ይሰማል አንዱ ጋር ደግሞ አይሰማም እና ኮኔክሽን ነው ማለት ነው ላኮ ኮኔክሽን ነው ማለት ነው
ሚስተር አንተ ይሰማል አሁን
ኢየሩሳሌም ይሰማል ወይስ አይሰማም
መሀል መሀል ላይ ይሰማል መሀል መሀል ይሰማል
ሚስተር
ኢየሩሳሌም ይሰማል
አዎ ይሰማል
እሺ ሌሎቹ ጋር እንዴት ነው ታዲያ አይሰማም እያሉ ከዛ ሊሆን ይችላል okay the other one is dimension of volume is equal to L is the power of 3. It is not negative, positive. So, for example, if you see this one, volume is equal to length times width times height. It is length is length, width is a type of length, height is a type of height. Therefore, the dimension of volume is equal to L is a power of 3 or positive 3. What about this one? Density, the dimension of density is equal to kilogram per meter cube. Kilogram is the unit of mass, So instead of kilogram, we represent by capital M. So in meter cube means, yes. Meter cube means
Mr. Aisama.
ይሰማል እንዴ?
ይሰማል ሚስተር ቀጥል።
meter
ሚስተር
cube
ይሰማል፣ ዝም በላቸው።
የእናንተ ኮኔክሽን ነው እናጠብቁ እየገባ የወጣ
እውነትን ነው ሚስተር። የነሱ የራሳቸው ኮኔክሽን ነው ሎኖ ኮኔክሽናቸው
እኛ ጋር ይሰማልና እናንተ ጋር ኮኔክሽን ያለው ነውና ትንሽ እንጠብቁ መስመር ላይ ያው ነው ትንሽ ለምን
ሚስተር የኛ አይደለም ኮኔክሽን።
እሺ kilogram is the SI unit of mass. The unit of the dimension of mass is capital M, as we have raised above. And volume means if you see at above, it is symbolized by L, the power of 3. So because of this, as numerator, when we bring up, it become negative 3. So the dimension of density is equal to ml minus 3, the power of minus 3. This means they are equal. For example, m capital per l cube, they are equal. So the dimension of density is equal to m l is the power of negative 3. Again, speed is the dimension of meter is the SI unit of length. When we represent length by dimension, it is symbolized or it represented by capital L. Again, second is the unit of what? The unit of time. So T capital minus 1. So the dimension of speed or velocity LT minus 1. What about force? Who can tell me the dimension of force? Who can tell me? Throw one of you. The dimension of force.
minus 2.
Yes.
MLT minus 2.
MLT minus 2. Yeah. M comes from kilogram. L comes from what? From length. T square or T minus 2 comes from time. Okay. So M L T minus 2. For example, kilogram is the SI unit of mass. Meter per second square is the SI unit of acceleration. For example, force is equal to mass times acceleration. So to write the dimension of a given physical quantity, you must know the formulas of the given physical quantity as well as the basic physical quantity contained in that dimension. Okay, in that dimension. For example, LT minus 2 is the dimension of what? LT minus 2 or L per T S. Yes.
Acceleration.
The difference between the units of acceleration and the unit of speed or velocity is L per T minus 1 and LT minus 2. The difference between them is for acceleration, the dimension of acceleration Lt minus 2, whereas the dimension of speed is Lt minus 1. Therefore, to write the dimension of physical quantity, you must know the basic physical quantity contained in that dimension, okay? In that dimension. Have you understand? Have you understand how we can write the dimension of a given physical quantity?
Yes.
Yes.
Have you understand?
Yes.
Yes.
Okay, okay. I think this is already written on your text.
Yes.
Take your text, you will see. You will see. Okay. The other one under dimension of physical quantity, the derived units are based on fundamental units. You know this one. You know this one. For example, Newton means 1 Newton is equal to, Newton is derived or fundamental units?
Right.
Newton is derived. So 1 Newton is equal to kilogram dot meter per second square. So please, whom you
Aramute አድርጉት።
mute አድርጉ። If you see this one, Newton is based on what? On fundamental quantities. For example, kilogram, fundamental, meter is fundamental, second is fundamental. Therefore, that units are based on fundamental units, fundamental units. Therefore, the dimension of units are expressed in general, m the power of x, l the power of y, t the power of z, where k is a number. For example, 10 Newton means 10 kilogram meter per second square. Have you seen? For example, 10 Newton is equal to 10 kilogram meter per second square. Kilogram meter per second square. Have you seen? 10 is, instead of k, 10 is a number. 10 is constant number. Constant number, where k is a number. For example, instead of this one, your k is k, m is equal to kilogram, l is equal to meter, t is equal to second in this one, if you see, and x is equal to 1, y is equal to 1, t is equal to or z is equal to -2, -2. For example, an energy of 10 joule can be written as by 10 ml square t minus 2, or t is the power of -2. 10 joule means, what is joule, by the way? The SI unit of what? Joule is the SI unit of what? The SI unit of
Energy.
energy, as well as the SI unit of
power.
Yeah. So when you talk about 10 joule, you can write as the form of what we have seen above, general. For example, 10 m, m means, for example, energy is equal to, tell me energy. Energy is equal to, for example, kinetic energy. If you take kinetic energy is equal to mv 1 over 2 mv square. Don't worry about 1 over 2. When we talk about it is, for example, let us see kinetic energy. Kinetic energy is equal to 1 over 2 mv square. mv square. Leave it about 1 over 2. Take the units of mass, kilogram, and times v square means meter per second, the whole square. Kilogram represented by capital M, have you seen? And M is when we symbolized by dimension L over T the whole square. So M L square T minus 2, T minus 2, the dimension of energy, the dimension of, this one is the dimension of energy. Look, this one is, this unit talks to you or tells you the dimension of energy, the dimension of energy. So here the value of K is equal to 10, this one. X is equal to 1, Y is equal to 2, and Z is equal to minus 2, this one, instead of Z minus 2. So the power 2, which is the fundamental unit, are ready to obtain the derived units, are called dimension of derived units. Dimension of derived units. Dimension of derived units. Dimension of derived units. So depending on the given dimension or what we are seeing above, we can write the dimension of physical quantity. The dimension of physical quantity, okay? The dimension of physical quantity. For example, some dimension of important physical quantities, dimension of velocity, the same as dimension of speed, okay? Dimension of velocity. What is the dimension of velocity?
LT minus 1.
LT minus 1. Minus 1, yeah. LT minus 1. For example, velocity is equal to displacement over time taken. Displacement means a type of length. Therefore, it's symbolized by L over T is capital T. When you bring up this T, it become minus, okay? It become minus L T minus 1. T minus 1. T minus 1, okay? T minus 1. So the dimension of velocity, Lt minus 1. What about momentum? Do you know what this momentum means? Momentum. Do you know what's the definition of momentum? Momentum is what? Maybe you didn't see it one. Momentum means momentum equal to mass times speed or velocity. Speed or velocity, or speed, you can't say speed. So the dimension of mass is equal to capital M, the dimension of velocity L minus 1. L minus T, the power of minus 1. Dimension of momentum is equal to what? What's the dimension of
minus
momentum?
1. MLT minus 1.
ML minus 1 is the dimension of momentum. Everyone, when we talk about dimension, it is from this formula, depending on this formula, we can bring out the basic unit content in the given body, okay? The given quantity or the given physical quantity. You know, acceleration, we have raised above. Acceleration is equal to velocity.
L.
What is the SI unit of acceleration? The SI unit of acceleration?
Meter per second.
Meter per second square.
Second square.
Yeah. So when we symbolize the meter by dimension, it is symbolized or represented by capital L. Per T square. Per T square. When we bring up the T or time square, it become LT minus 2. Therefore, dimension of acceleration is equal to
LT minus 2.
2. Yeah. LT T minus the power of -2 and the -1 are the difference between the unit dimension of acceleration and the dimension of what? The dimension of velocity or speed. The dimension of velocity or speed. What about energy? Yes, we have
Energy.
done at the above.
MLT ML square T minus 2.
ML
Yeah.
ML2 T minus 2.
L is a power of 2
L
and T is a power of
T
T minus
T
2.
T
negative 2.
Minus 2.
2.
Yeah, yeah. This one is the dimension of energy. The dimension of energy. The dimension of energy. What about frequency? Do you know frequency? Frequency means everywhere.
Frequency T minus 1.
T
No.
minus 1.
Minus 1.
T minus 1.
1.
That
1.
means frequency means per second everywhere. Per second means 1 over T.
Second.
Over T means T minus 2. What about power? Power.
Kilogram
Power?
meter square per second
No.
cube.
ML
Yes.
ML
Minus
2
ML 2.
كذا T the power of
For example, power
minus
means look.
3.
Power is equal to energy over time
ML
or
2
work done over
T
time.
minus 3.
Try to
Then
put
dt
this one and the charge again.
the power
It is given for you
the
by
dimension of
80.
power.
By 80.
Yes. Okay.
Try to summarize this one. I think it is, if you have finished, it is given for you by text form. And in our today discussion, how we can write some dimension of physical
Mister.
quantities we have seen.
Mister.
Therefore, try to understand and try to
Mister.
identify one dimension of physical quantity from the other one. Yes,
Mister.
yes, yes.
ደብተር እናዘጋጃለን። ደብተር
ደብተር ስለሱ አሁን ኢንፎርሜሽን የለኝም እና ስትመጡማ መዘጋጀታችሁ አይቀርም ብዬ አምናለሁ። ለምንድን ነው ትንሽ ሾርት ኖት መውሰዳችሁ አይቀርማ?
ሚስተር አሁን ኖት የሚላከውስ እንጽፋለን።
የሚላከው ደብተር ላይ ይጻፋል።
ለምን ትጽፋላችሁ? እዛ የሚላከው እኔ አላውቅም። ይሄን ኢንፎርሜሽን በቢሮ በኩል ጠይቁሽ።
ስልክ ሲደወል አያነሱም።
Mister, what about charge dimension?
ኮሮና ስለሆነ እኮ ነው የማንመጣው።
Mister, what about the dimension of charge?
80, okay?
Mister, don't end the meeting.
Yes.